Welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, we are here on day 9 where we are going to take a look at today's problem statement. The title says smallest subtree with all the deepest nodes. So we have given the root of a binary tree. The depth of each node is the shortest distance to the root. Return the smallest subtree. We have to return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has the largest depth possible among any node in the entire tree. The subtree of a node is a tree consisting of that node plus set of all descendants of that node. For example, if we have two, so in this example, as you can see, 7 and 4 are the two deepest nodes. So we have to basically return the subtree containing these two, which is the 2. So we should return the tree starting from 2. Okay. So in this way, if there was, let's say, another branch here, and, uh, and so 7, 4, and let's say another is 9 element which is here. So we have to basically return the 3 because 3 is the smallest subtree which contains all the deepest elements. Okay. So uh, from looking at the problem statement, it looks a bit difficult in the start, but trust me, such problems are very easy to solve. Let us try to find the intuition of it. So the problem states deepest nodes. So we want the depth. Okay. The keywords are we want depth. So whenever you hear depth, so this can solve using BFS and DFS, but I prefer to use DFS when the keyword such as depth is present. So I want to go to the depth. Apart from that, it mentions we have to return the subtree which contains that node. So even if it is there, even if it contains at two places, you have to return the common. So we have to return the common node. So uh, whenever uh, whenever these terms arise, what you can simply think of is LCA. Have anyone of you heard of LCA? Yes. So LCA is nothing but the lowest common ancestor. So isn't it similar to the same problem statement? Uh, how we will understand it while writing the code. So basically we will but it's a simple modification to the LCA with the given condition that we have to return the nodes subtree which contains the maximum deepest nodes. Now, while writing the code, you will be able to understand what is the approach. Let me take a helper function, which would be the recursive function, the root, and the level DFS level depth. Okay, now let me complete this int depth. Okay, initially my depth is 0. Let's say I reach to a point or there is no node possible. If root doesn't exist, I will simply return the whatever depth I am at current. Okay, because this condition can come at here as well, right? 0, 1, 2, 3. Here I might file empty, so I will return 3. So I'm returning the depth. Sorry, my bad, I mistakenly submitted it, but no worries. Yeah, so this is our base condition. Now, what are the other conditions? Now, whenever I'm at a given point, there are two possible depths, one depth coming from left, one depth coming from right. So simply declare two variables. One is going to left and another is going to right. So when I'm going to left, I need to pass root arrow left, and for right, I need to pass root arrow right. And whenever I'm going left or right, my depth increases by 1, isn't it? Whenever I'm going one level below, my depth increases. Yes. Now here are the scenarios that we need to consider. I want the maximum depth, right? So I can simply return max of left, comma, max of right. So what is this giving? So this function is basically helping me find the nodes, the maximum depth. But can I tweak something here? Let's say I declare another variable max depth initially assigned to int min, and I also want answer which I will return at the end. Okay, cool. So yeah, now what we will do, let's say I simply return the maximum amount of left and right. This is nothing but the depth I'm returning. Okay. Now consider, let's try to try run this. Initially I was at root. I went to left. Again I went to left. Now I made two recursive calls, one at the left and one at the right. The left one returned, since it was empty, it returned me 6. And similarly, right also, sorry, depth is 0, 1, 2. So 6 returns two values, 2 comma 2. So I just return the current node. Now what I need to do up till this point, what was my maximum node available with me? 2. Did I maintain it somewhere? I declared the variable, but I did not. I need to maintain it. So what I will do, I will simply add a condition which will update the max depth here. At each depth, it will update the max depth. Now, since I am at here, let's say the left and right, it returned me a depth of 2. But what is the answer at this point? If my left and right return the same depth, what does it mean? It means my current node is the answer, isn't it? Let's try to understand with this. Let's say my left return depth of 1, 2, 3, 4. Let's say my depth return, this two node return depth of 4, and this also return depth of 4. So what is the answer in this case? This current present element. So let me add that simple condition. If my left is exactly equals to right, and so whatever the, so in this case left is 3, this is also returning 3, the depth 3. Now I need to check the returning element which is 3. Is it my maximum depth? If yes, that is the answer. So I'll simply check. I can use left or right here. Left exactly equals to max depth, isn't it? In this case, what try to think what would be the answer. I'll update the answer. So answer is equals to current node. Current node is nothing but root. Okay. Yeah, simple, easy, cool. Now let us try to run this problem statement. Solution. Yeah, sample test cases are passing. Let us submit this. Meanwhile, let us try to discuss that. And yes, we have successfully submitted this problem statement. And it beats 100%. It means it's the fastest. Okay, now let us try to understand the time and space. Since, as you can carefully observe, we are visiting each node once. Are we repeating? No. So time complexity becomes O of n, where n is the total number of nodes. Similarly, what is the space complexity? Let's see if it is a skewed tree. The recursive stack goes one after one, so it also becomes O of 1, the recursive, right? Yeah, that's the time and space complexity. Okay, I hope the problem and solution is clear. Only tricky situation is uh, this updating the max depth. If you did not understand the solution, try to again go back and watch this, you will easily understand. Similarly, the other important condition is this: when left and right depth are equal and are of max depth, current node is the answer. So that's the only place where we are updating. Okay, I hope I am able to explain this clearly. If you have any questions or doubts, please do let me know in the comments. Thank you.